Hello, I'm Don Machholz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 87 for the week of September 1st, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, September 1st, the moon is a crescent in the morning sky. During this week, the moon will be new. That will be on Tuesday, September 7th, a few minutes after midnight Universal Time, 0051 UT to be exact, on September 7th. The moon passes north of the sun. Those wanting to see a thin crescent moon this month, the northern hemisphere is favored for seeing the moon in the morning sky before September 7th. The equatorial and southern hemisphere is favored for seeing the thin lunar crescent in the evening sky on and after September 7th. By next Tuesday, September 7th, the moon will be a very thin crescent in our evening sky. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, September 1st through Tuesday, September 7th? It all depends upon where you are located. This week we have 6 zones. All you need to know is your latitude. North of 64 degrees north, you won't see it at all. From up there, you hardly ever see it. From 37 to 64 degrees north, the ISS will be in your morning sky for the whole week, and some nights you might be able to see it twice. From 12 degrees south to 37 degrees north, the ISS will not be visible at all this week. From 33 to 12 degrees south, the ISS will be in your evening sky for only part of the week. From 50 degrees to 33 degrees south, the ISS will be in your evening sky all week long. South of 50 degrees south, you won't see it at all. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Now for the comets that we can see in our sky this week. Last week I introduced 4 comets visible in the evening sky, although one of them, Comet 2021 A1 Leonard, is about 35 degrees due north of the sun, transitioning into the morning sky. This week we will add 4 more comets to the mix. They are plotted on podcast 87, map 3, Comets, and the positions for all 8 comets, right ascension and declination, are on podcast 86, comet positions, which was part of last week's handouts. You can also get the positions for these and other comets from the website heavens-above.com, then click on Comets. So, here are the comets. Periodic comet 4P/Faye, F-A-Y-E, will be at its closest point to the sun on September 9th at 1.6 astronomical units. That's 1.6 times farther from the sun than we are. This comet comes around every 7.5 years. Over the next 2 weeks, Comet Faye passes through the constellation Taurus at magnitude 10 to 11. You will need a telescope to see it. Periodic comet 15P Finlay. Now this comet orbits the sun every 6.5 years and was already at its closest point to the Sun at 1.0 astronomical units in mid-July. It's presently magnitude 11, and it's passing through the constellation Gemini, moving just south of the star Pollux on September 19th. Periodic comet 8P Tuttle is emerging from the solar glare, but if you can see it, it should be about magnitude 9 to 10. It was at its closest point to the Sun, 1.0 astronomical unit, on August 27th. But it was on the far side of the Sun, so it's far from us. It orbits the Sun every 13.6 years. Finally, Comet C 2019 L3 Atlas is north of the constellation Gemini and shines at magnitude 11. This comet never gets close to the Sun. It reaches its closest point in early January 2022, still 3 months away. At that time, it will be a very distant 3.6 astronomical units. A few weeks ago, I was comet hunting and picked this one up, and for a few minutes thought that maybe it was a new comet. A quick look at the heavens-above.com website under Comets showed that this was a known comet, then magnitude 12. This week, we have 2 projects we can do. The first is to see the shadow cast by Jupiter. I'm not talking about the shadows cast by the moons of Jupiter onto Jupiter, nor am I talking about the shadow that Jupiter casts behind itself, made known when its moons pass into that shadow. I'm talking about the planet Jupiter being a light source that casts light on the Earth, and you being able to discern a shadow of something in its path. If you can see the shadow of something, then that means that you can see around it the light cast by that object. Jupiter is presently in our evening sky, and from the northern hemisphere it is in the southeastern sky at nightfall and moves across the southern sky as the night progresses. That bright spotlight is Jupiter. We did this experiment with the planet Venus last year, and I described it on several occasions in this podcast. Yes, it's been known for a long time that Venus can cast a shadow. The Sun does, the Moon does, and so does Venus. The difference, however, is the brightness of each object. Venus at its brightest is magnitude minus 4.8. Now, on the magnitude scale, the higher the negative number, the brighter it is. The Moon is about a minus 13th magnitude. Venus at its brightest, as I just said, is minus 4.8. This year, it doesn't get quite that bright. It reaches minus 4.67 in early December. But right now, Venus shines at magnitude minus 4.05. Now, the same techniques we will use for spotting Jupiter's shadow can also be used for Venus's shadow. With both objects in our evening sky, you might want to try to see both. The challenge here is that Jupiter is fainter than Venus. Presently, Jupiter is magnitude minus 2.86. By the end of September, it will still be bright, but will have dimmed by 1/10 of a magnitude to minus 2.76. So Venus is more than twice as bright presently than is Jupiter. This week the Moon is out of the sky, so let's give it a try. There is a published report of a professional astronomer easily seeing Jupiter's shadow while inside the observatory dome. Inside the observatory there is no stray light. In his case, only Jupiter's light coming through the observing slit in the dome. This occurred in 1905, more than 100 years ago. A similar method can be used by you this week to see the shadows cast by both Venus and Jupiter. Do one at a time. For Venus, the easier one, it's in our western sky each evening. Go into a dark room, shop, garage, or big cardboard box which has a window facing the west. Turn off all the lights so it's really dark. The light of Venus is now streaming through the window, falling on the floor, and if Venus is low enough, some of Venus's light falls onto the far wall. Can you see it? It helps to wait at least a few minutes for your eyes to become dark adapted, and use both eyes for better contrast. What works for me is to wave my hand with my fingers spread out in front of the wall and watch for the subtle shadow on the wall. Being nearsighted, I remove my glasses and get really close to the wall. The shadow will have sharp edges. Ignore any diffuse shadowing. That is from sky glow, light pollution, or starlight. Okay, so try that for Venus, magnitude minus 4.1 right now. Next, we move to the planet Jupiter, about 3 times fainter. The technique is the same, but you might have to find a different room as Jupiter will more than likely be higher in the sky and south if you are in the northern hemisphere. The shadow is there. The problem is seeing it. Recently, a Canadian amateur astronomer did an experiment where he used a sundial type of setup inside of a cardboard box with a center post that cast the shadow of Jupiter. This amateur astronomer did not make a visual observation, but used a camera to attempt to image the shadow. And he did image the shadow. So it is there. But can you see it? This is more of a test of your eyes and skies than of anything else. Seeing low contrast objects is not easy and takes practice. The other way to see the shadow is to stand in front of a south-facing white wall, perhaps your house, and seeing if you can see your shadow as you move around a bit, or dance. The motion will make it more easily discernible, and dancing in the dark is okay because no one will see you. Remember, it is dark. So let's try that experiment this week, seeing the shadow cast by Jupiter. Give your eyes time to become dark adapted. It does make a difference. And use averted vision. Look a bit off to the side, but concentrate on where the shadow should be. Our second project concerns a single star, a fast-moving star called Barnard's star, named after astronomer E. Barnard. This is the fourth closest single star to us at a distance of 6 light years. You need a telescope to see it because it is magnitude 9.5. It moves comparatively rapidly across the sky. Now, all stars move or appear to move across the sky each night. Now, that's caused by the rotation of the Earth. But the stars generally stay in the same patterns in relation to each other. Stars are far away, and even when moving many miles per second, they hardly appear to move. Barnard's star is the exception. It moves 10.3 arcseconds per year, and in 60 years it moves a distance of 1/3 of the lunar diameter as seen from the Earth. Now that is 10 arc minutes in 60 years, 3 arc minutes in 20 years. It doesn't happen overnight. Barnard's star is in the constellation Ophiuchus near the equator. Now, in your lifetime, you should be able to detect this moving star. So, this week or next week, or sometime in the next few weeks, Go out and use this map, Podcast 87, Map 4, Bernard Star, which consists of 3 maps, and put a pencil mark or pen mark, something that will last a long time, on the map where Bernard Star is now located. Put this map away for about 20 years. Then get it out and see if you can detect movement of the star in the intervening years. The maps that I provide are, first, a star map drawn by a computer program called the Sky. That shows the approximate position of Bernard Star so that you can begin to center in on it. Then I include both a wide field and narrow field of view from the remote telescope system called LUWD. In the case of the photographs, I reverse the photographs so that the stars are black and the sky is white or gray. Oh, I also did one more thing that will make it easier for you to plot the star honestly and accurately. I removed Bernard Star from the photograph. I blotted it out, but I left in the surrounding stars. So the location you mark is your location for the star. We're doing real science here. Podcast 87, Map 4 has a star map showing a large part of the sky, a wide field, and a narrow field of view. Use those 3 maps to plot Bernard Star, and you'll probably be plotting it on the narrow field view, the last of those 3 maps. Put it away for 20 years, then see what happens. To recap the podcast, what's up this coming week? The moon, a crescent, passes from the morning sky to the evening sky this week. 8 comets are visible in our sky this week, all needing a telescope. Look for the shadows cast by both Venus and Jupiter, and plot the position of Bernard Star. You have been listening to Looking Up with Don, podcast episode number 87 for September 1st, 2021. I'm Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DonMachholz.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that's dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky. Our most distant major planet comes to opposition next week. All that and more. Thank you for listening. See the sky this week. I'll see you next week.